So last week I was saying I got my those encoders. Um, if we go back to not let's don't do that. Oh, so I got those encoders. I was going to mount them on this vehicle right here because it's already got encoders on it. It already moves. I can drive around with remote control, and it's currently set up where it will log the encoders that are on the wheels to a bag file, so we can go back and look at it later. So I was going to put the new ones on that. And as opposed to the lawn tractor, it's hard to get into it and work on it because I can't take them apart like Al does. And so that seemed like a reasonable thing, just bolt them on here, but it still took me like a week of just sitting there thinking about it. And then I finally got around to make some brackets yesterday and got it all bolted on. So if we do this, share screen, screen one, show me. Okay, so that's the stuff we want to see there. I don't know what that picture is. Well, we'll see. We'll see what happens here. Let's see. So anyway, I've got this.
Obviously, I'm seeing Slack.
Oh, I know it's gone. It's my background is yeah. It's Slack. Well, how come you share the screen? Oh, this is bizarre here. I'm seeing the background. Apparently, some Windows background they put up. So anyway, let's assume this is going to work. So I come back here.
Just so you know, I see the random channel in Slack and a picture of your
Yeah, that's what I want to show, but
odometry wheel.
but the Zoom is trying to help me out again. I think is what's happening. So I'll move it. So anyway, so I put out this post saying, yeah, I got around to mounting this on the thing, and I found a box full of sensors that were lost. So we'll go look at the first picture here, and this is just a side view of the thing. And if we zoom in on it, so here's the thing that I bought on Amazon. So it has this T-shaped aluminum bracket that you bolt onto a frame somewhere. That's got this long steel shaft through the side here. And when we look at the next picture, you see you can loosen this set screw and then slide it in and out, so I can get lateral adjustment to get the wheel over the center of the tire. Right here, you can see there's a molded on the tire. That's the center of the tire because when they molded it, it's got this ridge that runs down there. So one thing is you want to adjust that to get it right over the center if you can. And basically, it's just a matter of I cut this aluminum bracket here. It's a piece of extruded aluminum. I think it's like 1.5 inch aluminum angle. And then I drilled holes to bolt it on here. Then drilled holes to bolt it to the side of my roll bar that's on my vehicle. And it does have a spring that it's got this collar on here. Here we'll go to the next picture. And if I go look here, so I was saying that if you loosen the screw here, you can slide the shaft back and forth, and that allows you to move the wheel back and forth. And see, here's that mark I was talking about. That's molded into the tire. That's the center line of the tire. So you can just move the thing back and forth until it lines up with that. And then it's got this collar. I think it might be a steel collar, and it's got three holes drilled in it with these three Allen head screws sticking out of it. And the one in the back here, it's got the spring hooked onto it, and the spring then runs up and then hooks on up here. So it's a way you can adjust, you can add extra spring tension to hold the wheel down. And let's see, it's going to say, do I need to change screen modes? But no, I'm sharing my screen, so this should all be coming through directly. Um, and then it's just simply, it's got the steel rod that's threaded, and they've got this bolt, and this is a bearing that they've stuck into the aluminum plate. And if you look at last week's meeting, I was talking about this and holding the thing up. And I think I posted a link to Amazon where you can buy these and you can get better views of what's going on. So anyway, I got that mounted on there. And there's one on this side. I got the one on the other side mounted. And right now the cable is just dangling down here. So I gotta take these wires and hook them up to something And so the next step is going to be, I'm going to have to pick some random microcontroller to hook this up to. So let's see, I should be able to stop sharing. Stop sharing, he says. Stop share. Okay, there's me. Let's go to a big view. Big view, and I decided I have to. Pardon me for narrating all this, but I realize there's several steps. I got to turn off my background. Otherwise, everything's transparent that I try to show. So we'll say turn this off. And then if I say turn on or switch cameras, well, here, let me clarify that. So go back to the first camera. So I was digging through my box of junk. I ran across my borescope camera, and this thing is about the diameter of a pencil or smaller than that. And it's like 3/16 of an inch or whatever, and it's got lights in it, and it's got about a 2-foot cable on. You can plug it right into your laptop or into your cell phone. So now let me go back just to show you what this camera is that I'm using. So when I was digging through my box of fun stuff, I found this box of stuff. I ran across these. These are Hall effect sensors. They're basically like it's built like a transistor, but they're flat. It doesn't have the round, one side isn't round like a transistor would be. So it's just kind of a flat thing. And you can buy them loose like this. So you just put power on them and then hook up a signal to it. That's the next thing I need to go to. Or you can get it. Oh, I'm sure I'm sure it's gonna make people sick with me moving all this around like this. So anyway, you can also buy it as a printed circuit board, and it's got one of those chips soldered on it, and then it's got an LED on the board, and it's got a place where you can plug in, your jumper wires to it. So you can buy it either way, and it just depends when you're trying to do it, what would be the easiest way to try to mount that. Then also in that box of stuff, I found one of my what I call industrial Hall effect sensors, and this one is it's just it's built like those proximity sensors, so it's got the wire coming back. There's an LED on the back of the thing, so if you put power on, you can see the LED go on and off as you move around. So that's a handy thing to have that on there. And it's just got a threaded shaft and some nuts, so you can just basically just drill a hole through a plate, push the thing through there, and then adjust these nuts up and down, so you can adjust it, in and out like this, just by adjusting that stuff. And this is the one I was thinking about putting on the flywheel on the lawn tractor, because being a Hall effect, it has to have a magnet for it to activate, and the flywheel has magnets that they're spinning around. So that's a good thing. And then also in that box, I keep saying every meeting, I hold up a sprocket on a wheel and say, if I had my proximity sensors, and here's one of the proximity sensors, and you can see it's got an LED on the back, and then it's built the same way, where it's got the big threaded shaft, the big threaded housing, and it's got nuts on there. So again, you drill a hole and you adjust it. So you can mount it so the plate's here, mount it so the plate's here, and it sticks out quite a ways. So anyway, these are the ones that you put power on them, and then you get them close to ferrous metal, and they'll turn on. So you don't have to have a magnet anywhere; it can just detect stuff. So let me switch back here from anything else I want to show. Yeah, let's switch back. So let's see, camera. Let's say this camera. So every meeting I was holding up something, say, well, here's a sprocket on a wheel, and if you had a sensor like this, you can sense it. Well, now I have the sensor, so basically you could either I'm going to experiment to see, do you want to read the tip of the tooth as it goes by, or what Matt said he was doing was he had it like this, and he'd bring it in to look at the teeth, look at the side of the teeth as they go by. And I'm going to have to experiment and see if it'll work. So I just want to get a stand. It's got a 3/4 inch hole in the thing here. I'll just have a 3/4 inch bolt standing up, and then put it on like this so I can spin it, and then either just hold it here by hand, or maybe mount it on a bracket like this or something. But that'll allow me to see if, number one, if this is going to work at all with what I have. This is a smaller sprocket. Matt had a number 50 sprocket. This is a number 35. So I think the number 5 is 1/2 inch space between the teeth, and I assume the 35 is like 0.35 inches between the teeth. So the spacing of the teeth and the size of the teeth compared to the diameter of the tip on this thing will determine how well this stuff's all going to work. So that's something. Now that I found that in that box of stuff, that I can get on with that now. One of the things I wanted, I look at this box down here. One of the things I want to show, I was saying that on the showing the picture of the my Sammy mini tractor, and it's got those brackets with the encoder bolted on and the encoder wheel. Well, it's the same concept as this. You can buy these. I bought this at Harbor Freight. This is I refer to this as a rolling tape measure. This stuff's all backwards. And if I turn it on, you turn it on, and it's got some kind of electronic counter in there. So basically, it just has internally, it's got an encoder, which would probably be inside of here. There's an encoder, and it's just got a wheel on the end of it. So it's the same concept as using that wheel. And if we go watch the thing while it's running here, let's get right side up. And basically, as you start pushing it along, it just measures. Right now, it's set to feet. This particular one you can set to feet or meters. That's this one. So there it is in meters. So as you drive along, it just simply counts how far you've gone. If you go the other direction, it counts. There's counting up. Let's go this way. So it's counting down. I think it'll go. Oh, this one won't go negative. That's cute, but it goes back down to 0. And on the robot stuff, I want it so it goes negative, and I don't know why they decided to do that. But so anyway, you go this direction, it counts up. So it's the same concept. It's like this, but it's just simply I could take one of these and lay this on. Here's the say here's the wheel on my vehicle. I could just lay that on top, and it would do the same thing. So as you drive along, it would do that. But I wanted it so I could read it in the computer and do it that way. So anyway, that's something else that I thought of would be a good demonstration of something. So then back to my encoders. I'm not going to turn my background back on yet. So on my encoders, I've got I said I just got the wires hanging out. I have to hook it up to something to actually make it work. So I was digging through. These are the blue pill boards. It's like a $3 board, and it's got an ARM F103 processor on it. And this particular chip you can run up to 4 quadrature decode channels. It's got hardware built in to do that. And then here's just a different one that you can buy on Amazon. This is they might call this the black pill, or I don't know what they call it, but it's got like the ST micro, like either F401 or F411 chip on the thing. And I'm not sure which is on this one. This is probably the F401. One thing I don't like about it's got the stupid little dip switches on here. I can switch the other camera and give you a close-up view of that. But anyway, it's got this little tiny dip switch that instead of having jumpers on it, the other boards had like this, where it's got the jumper. You can pull the jumpers off and move them back and forth. And then some of the boards have push buttons, so you hold down the boot push button, and then press the reset push button to get it to do all the boot type stuff. But this particular board has a USB-C connector, and those seem to be much more sturdy than the micro USBs that's on the other boards. And apparently I've had this one running because I got these 2 pots on here, and they're hooked up to the board. And then I will probably program it. To start off, I'm just going to use one of the little external programmer modules. You can also buy these on Amazon for like $3 to $15, depending where you buy it and how many you buy. But that will let me so I can either use this board or the blue pill board. Again, this board here. So I can use either one of those and program them directly with the big ST Micro IDE. I could go play around with the Arduino stuff, the Arduino IDE, but I think it's going to waste a lot of time. So I'll just go ahead and do it with the ST Micro stuff. And as reference, here's this is the board that's in my robot right now. It's just one of the eval boards from ST Micro. It's got the big processor chip in the middle, and then down at the end, it's got this whole section here is the equivalent of that little. That's the equivalent of one of these that's built right onto the board. So you just plug in a USB cable and hook it up, and program and stuff on the IDE. Hit the download button, it loads on, and you're ready to go. This is what I was using on that. And then Juan found out you can't buy this board anymore. So he found these on Amazon. It's basically the same chip, just on a board without all the extra junk on there. And it's got the only other thing it has, it's got a here's a I think that's a voltage regulator. And down here, that's some kind of like a serial. It's either a serial flash or a serial RAM, I think. So it's got like, half a megabyte of some kind of storage in that thing. And it does have an SD flash card socket on it, which I've never used. And this one's got a couple, I think these are push buttons here. Yeah, those are push buttons. So, to boot the thing up or whatever. But it's also got these jumpers on the end you have to play with to get it to boot correctly. But again, if I hook up the little dongle like this to it, once I get that hooked up and figured out, that it's just a matter of saying program and away it goes. So that's my choices. I just need to pick one of those. And I think if I load up the IDE, I'm going to find that I probably have a project sitting there that it probably says blue pill, USB, and 2 encoders. And if I find that and load that and try it, then um, that should give me what I need to make this stuff work. And then also digging through a box. Here's something about a surplus store one time. This is essentially the same thing as those encoders I just put on my vehicle, where it's got the standard, what they call the heads encoder. And heads is, I think, for Hewlett Packard. Is that where it comes from? And this probably isn't going to show up, but there, right there, it says, come on. Someday I'm going to figure out the trick to get this to focus. I think it's focusing on me. Anyway, it says HEDS 5500 AO6. So these are just standard encoders. You can buy the plastic encoder, and this one just happens to have a long shaft on it. And then it's got some kind of, it's a little rubber wheel on here. So it's doing exactly the same thing. This is what somebody, since I bought it surplus, somebody had this on their machine. And when they're done, they just dumped it in surplus stuff. So that's how I ended up with it. But I only have one of these, so I don't have two. And it'd be nice if the wheel was bigger around if I'm trying to read the wheels on my vehicle. So, and then here it came from Axeman surplus, and I paid $2.95 for it. So that was something cute I ran across, and that's basically what we're doing right now. So let's see, did I talk about my camera? Yeah, I think I talked about this, that you can buy these on Amazon for like $10, and it says it has a 3 to 8 millimeter focus range. Here's the back of this. Oh, let me switch cameras. So here's so you get nice and close with it, and it's small enough you can shove it down your drain or shove it down a crack or look behind something. Look underneath, say look underneath your refrigerator. And let's see, where's the top? I marked it one time so I can tell where the top is. So let's do it like this. There. So I've got a board at a weird angle, and I'm just turning the thing so it lines up. Let's see, it shows you and as Al was pointing out, you can actually read the chips if you get this lined up right.
Seems to need a little bit of an angle.
Yeah. And I could adjust the light up and down. Anyway, you can see these cameras are real cute and they're real cheap. And you can either plug it directly into a cell phone. You have to download some kind of app that says, talk to my camera, or they give you a little adapter cable when they come with it, and you can plug it in your laptop, which is what I'm doing. So that anyway is so that's no, my mouse isn't working. So that's something that's handy to have, and they're cheap, and you can just stick it in a box and lose it like I did. So let's see, anything else I was going to talk about? So basically, the status I'm at, I got the encoder bolted on the robot. I just got to create a little microcontroller board to read that. And then I can take it out and drive around the block and see how this stuff compares. This one, okay. And look at my toys here. No, I don't have anything else I want to show, I guess. So I'm done.
If you have the inclination, there might be something out there on YouTube, but using that STM programmer and just doing a blink program into that blue pill, I think would be a pretty well watched episode.
And you can get a standalone programming software for the ST micro stuff. So you just download that and then say give it a hex file and it'll load it on your board. So technically, if somebody would write up, say here, yeah, as you say, here's a blink program or whatever, and just get that software and say here's the hex code, and you load it on the board, then your LED will blink. Or say here's one that'll read two quadrant encoders and spit it out the USB. You can just download that. So you wouldn't have to have the full development system, and you don't have to, you say you don't have the full compiler, and you don't have to fight with all their libraries. If it's something that people think, yeah, I would like to have that, you could just put that out there, and anybody wants to could load that up. So that's something we can think about one of these days.
It looked like good progress getting that apparatus mounted to the wheel. That things fit nicely for you that way. So that was really convenient.
It doesn't fit exactly the way I want, but it's close enough that it's good enough to try it and verify if this stuff's going to work or not. And that's what I was really after.
It's like it was almost made for it. That bar was right in the exact right position.
It'd be nice if it was like 2 inches further ahead, because I see on my thing here. See, here's the axle right there. It'd be nice if the wheel was straight up on top of it, but the
Uh,
wheel's actually back a couple inches from the center. But when I started looking at it, I really didn't have a lot of options there where to put it, because in order to be able to slide the thing back and forth to get the centering adjustment, that steel rod has to be able to clear the piece of wood there. So that actually goes behind that. And let's pull up this picture again. Da, 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 da. And now, how do I get this on the screen? I say share screen, screen one. Get this junk out of the way. So if you notice here, it's back. Can you see that picture?
yes.
Okay, so here's the roll bar. Here's the piece of wood sticking up that's painted black. And see, I've just drilled holes for that. But in order to be able to adjust this so I can slide the thing back and forth, can you see my cursor on the screen?
Yes.
So some views you can see the cursor and some you can't. So I like to ask. I don't want to go for 2 minutes saying, "Oh, here you can see here," and you can't see anything. But anyway, I got that bolted on. So in order to slide this back and forth, see this steel rod has to miss this piece of wood coming down. So that's why it ended up getting mounted where it did. So this thing is just basically back far enough to clear that, and then vertically, it didn't really matter too much vertically. The higher I get it, the sharper the angle will be. Which let's see, right now you can't really tell from that one. If I back up one, so if I were to move this, here's the bracket on there. If I were to move the bracket up, what it does, then this would come down at a sharper angle like this. Or I could have moved the whole bracket down like this, and then got this straight across. And I couldn't decide if I wanted this straight horizontal or I wanted it down at some angle. So I just picked a spot, said that looks close enough, and I'll go with that. So that's where it is right now. And
Cool.
it sticks out more than I prefer, but again, it worked out fairly well, so I didn't worry. I see the whole thing's not symmetrical because I want to put these bolts in through the roll bar here. On one side, I can push the bolt into the back. The other side, it hits the plastic boxes. So I had to unsnap the box and lift the lid up and then put the bolts in. And it could be the one tire might stick out further to the right than it does to the left. So, but I've got that adjustment on it. So that should allow me to do that. So it really now it's just gonna be a matter of, as I say, hook up the microcontroller and take it out and drive around and see what the thing's going to do. So that's where I'm at the moment. Oh, the other point is the computer I'm sitting here playing with right now for these videos, I think is the one that has my ST micro development system on. So I think number one, I need to click on that, see if it'll load up and run. And if it does, if I go to my projects, I think I have projects that were when I was playing with the blue pill and the black pill and tried to get the encoders to work. So hopefully I've got something there that would mostly work anyway. So let's see, stop sharing. Okay, so I'll turn it over.
Well, let's see, what do I got? Oh, shoot. Machine went to sleep. So more PID testing for me. I'll talk about that in a little bit more detail. Um, Doing some programming in the ODOM, getting
Okay.
ODOM from GPS.
Can you zoom in a notch or two on that so it's a little bigger?
Sure.
That's good.
Um, Programming on the GPS, talk about that. Thinking about tele-operation, and then just where I'm, what I'm going to do today and tomorrow and the next day. So previously on PID testing, I had gotten to a point where I was happy with, in my PID, I've got a minimum value that's sent to the transmission control servo. And I had 300, and then at the end of the mission, it was getting 300, and that was causing it to not stop. So I reduced that minimum value to 295, which triggered more PID testing. Um, and so I've done considerable number of different PID settings, 20-ish maybe. And I'm still not very, well, I'm not happy at all with the speed control. So I'm going to go back to this 300 setting and make sure there's another way to stop the tractor when the mission is complete. So some of what that looks like is yeah, I mean, you don't need to see an oscillating chart, but these are just my notes. So this is just an example of, the variability of speed. So I'm trying to get it to go half a meter a second, which is the blue line, and it's going up to, I mean, it's just a very sort of traditional oscillation going on there. Um, so I think I have a path forward, and part of that path is to change some code. This happens to be in the tractor control script. 2 represents being in auto mode, and change some code in here so that if I'm getting a linear x and an angular z of 0, then to send a neutral value instead of going to compute the PID previously. I was just, if linear x is greater than 0, go calculate the PID and feed that back into the transmission. So that's a little bit of what I've got to test now, and that's been keeping me busy for a few days. The other thing that I was going to mention was in the ODOM, getting ODOM from GPS and the wheel encoders. I discovered, even with an RTK fix, that the lat long would jump enough so that if you calculated speed on the movement between GPS points, you would get something like 3 meters a second, which is obviously not what the machine was running. So it was a true jump. There's probably a technical name for it, but there was a jump in the GPS setting, and it would come back and settle down. So it was, at this point, it just, I'm going to call it an abnormal reading, even though I've got RTK fixed. So I've gone back into the odom from GPS to add some more logic around if the speed is something that above a setting, and I just set the max allowed speed to 2.5 meters a second, then it takes an average or uses the average of both in heading and speed and calculates the new position. So in effect, I don't know if you want to be ungracious, a hack on calculating a new position in order to try to smooth that out a little bit. And when I was adding this code in, I got down into my, callback function, which is where that's called from. And I'm like, oh, this is getting a little unwieldy. So I added a few more functions to try to make this a little bit easier to understand. So that's what I've been doing on
How,
that.
how long does that GPS take to recover? So you're driving along and all of a sudden it jumps somewhere. How long until it comes back to where you say it's working again?
In my experience, one reading. Um, so, and I'm getting 5 hertz data. So 200, what did that be? 200 milliseconds. So it's only, I get 3 good readings. I get an odd reading, and then it comes back to what, if you calculate speed, the calculation goes back to a normal speed.
You could just simply monitor it, and if it says, "Oh, gee, the value that lat line I'm supposed to get all of a sudden just moved by some pick a number and say it moved by half a meter or whatever thing's jumping, and say if it did that, just simply skip one entire cycle if you're expecting it to come back the next cycle around if you expect it to be right again. So that way you don't have to do any averaging or anything. Because as soon as you start averaging, you're going to start slowing things down, and you might just be hiding problems. But if you could just, if it only happens one time, if you just ignore the one sample and just skip it and come back around next time, so don't do the calculation based on that. Just you're expecting it to come back the next time. Now you might want to say if it does it 2 or 3 times in a row, then you've got a problem, and then you can either shut down or whatever. But that just might be a quick way to ignore it if it's just a spike of data that
Yeah, that's good
just
input.
comes and goes.
I mean, I could strip that out. I'm also keeping track of the number of times that I get that. Um, oh, that's non-RTK. That's the quantity of times I get that. Not sure if I calculate the number of times I've got the abnormal speed. Um, oh, good suggestions. I'm not sure if, well, anyway, that's where I'm at the moment, is trying to deal with what I can recall others mentioning, that GPS jumps. I always thought they meant, yeah, it jumps if you don't have RTK fixed, but now I'm realizing it can jump a little bit when you even have RTK fixed. What else did I want to mention? Oh, also, I mean, when I'm parking my vehicle, I'm typically going in reverse, or if I've gotten in some sort of odd situation, I'll go in reverse, and I didn't have code in there to handle tracking the speed in reverse. And it throws off my plot juggler images, so it gets really way out of bounds. So I've also started adding code to handle reverse speeds, and by handle, I mean just track it accurately. Nothing, don't do anything other than calculate it accurately. Let's see, also considering, what if I ever wanted to tele-operate this thing, what would it take? Um, I don't have a camera on mine. I don't necessarily have internet access all the time, but if I did, I'd have to, be able to talk to this thing over the internet some way. But anyway, that's just a thought process at the moment. Next steps, change mission plan to 1.0. Let me explain why I'm saying that. If I go to some of my plots, this is me. So this is I don't know, 3/4 of an acre plot, maybe, and maybe more, like a half acre. And I run circular paths. The path is to run these circular rings to give it, I think you call it headspace or headland, so that they could then run a series of back and forth stripes. That's what I call them. This is an object in the yard that I'm driving around, and you can see that my adherence to the goal is not very good. Um, I mean, it's generally there, but it's nothing like what I wanted. Previously, I was testing just a straight line back up and forth, and I posted on Slack, I got it to look, you know, I would say very good. So the look ahead in all of these is 2.5 meters. And so my resolution or next attempt is going to be to change that look ahead to 1 meter. Previously I'd reserved 1 meter look ahead just because it generates so many points to the turnarounds or the keyhole or the Dubin's turn um, in path planning. But I'm going to go back and put that in for all of them and see if I can get a better adherence. This happens to be a plot of the variance to the path, and at the same time what the angular z value is. And let's see, I made a note here. Well, if you have to sort of look at two different things at the same time. So this is a zoom in on one particular point, and this red dot is the look ahead and the path that it's meant to be following. The blue line is the actual path that it took. And this calculation of the blue line to the red line, if I go back up to this data, I'm getting a little bit of an off-path error and a calculation of angular z of 0.05, which is, a very mild turn. And I'm like, wait a second, you're farther off than you should be generating something more aggressive than that in my book. And looking at the code inside of Pure Pursuit, that steer angle is using the YT value, which is this, what's referred to as lateral error. So I think the only way to, well, my most direct way to try to get it to be adhere to a little bit tighter is to reduce that look ahead value. So that I think is oh, and then the last thing I was just going to mention is, or show you, I had posted on Slack for Bob a little bit of effort that I spent on using a Linux or Ubuntu display manager called XFCE. I had never spend time on it. I mean, this is the traditional Ubuntu, I think it's called Genome Display Manager. You get this stuff over here on the left, and you get applications coming up like this. Well, this is what a screen looks like with this XFCE. And I actually like it. This is a different computer, but it's more like you can leave your icons here and you don't have to change. You don't have to go to, it just seems a little bit more efficient. Um, and the reason it seems to work for me is this computer has less memory. And you're on video, by the way. Um, and it just worked. So I posted some instructions and hopefully that'll help Bob out. That's it for me.
I guess I'm done too.